Hello, I am Dr. Sawant today from J.A.T Arts, Science and Commerce College for Women, Malegaon Dist-Nashik. Today's topic, which I had selected, that is a lithosphere. So, while discussing to this lithosphere, the composition of the lithosphere, we will discuss. So, vocabulary of the lithosphere, which is having the various parts. So, lithosphere, which is having a those parts that we will discuss. So, crust, mantle, asthenosphere, pedosphere, inner core, outer core, plasticity, convection, radioactive decay, 6 steps of rock cycle that we will discuss, and uplift of the various processes which are being acting part in the interior of the earth that we will see. First of all, what lithosphere is that we will see. So, the lithosphere includes the study of the origin and interior of the earth, the forces that originate within and outside the earth, which are responsible for creating various relief features on the surface of the earth, the earthquakes and volcanoes with their causes of origin and effects. It also studies the processes of weathering and erosion as well as the landforms that come into existence due to the erosional and depositional work of running water, moving ice, wind, groundwater, and waves. All these fall within the scope of physical geography. So, while studying to this, as we have seen that the lithosphere is the solid earth, which is one of the sphere which comes in physical geography. So, this is the study which is of the interior of the earth, and hence the interior of the earth has always remained a mystery to man. Man is able to study the atmosphere for hundreds of kilometers with the help of various devices such as the satellites. He is able to go down to the deepest part of the ocean, but he is unable to go deep down into the earth's interior. All the same, geographers are interested in acquiring knowledge regarding the interior of the earth as the surface of the earth changes due to the forces that originate far below in the interior. Sudden changes like volcanicity and earthquake, as well as slow movements like folding and faulting, originates deep within the earth, but man is unable to study the interior directly. At the maximum, he can penetrate up to a depth of 9 to 10 kilometers. As in the case of the deep gold mines or oil wells, this depth is quite insignificant when compared to 6,367 kilometers, the mean radius of the earth. But beyond this depth, his knowledge regarding the earth's interior largely depend on indirect evidences. So, geographers and geologists have collected the following information from indirect evidence regarding the interior of the earth. So, the first slide, which shows the solid layer comprised of crust and asthenosphere. So, this is one of the slide. In this slide, if you'll see the solid layer the circle which is made, that is a crust. So solid layer comprised of the crust, and it is also called as a asthenosphere, which is above the mantle. So these are the layers which are being shown in this slide. So as a lithosphere, this is the crustal and uppermost solid mantle, and these are the layers which are being shown over here as far as concerned to the scale which is given. Second one, the lithosphere. Here asthenosphere which is shown, this is also a solid layer comprised of the crust and which is above the mantle. So on this asthenosphere, a land surface which is on the earth, and hence a mountain, folding mountains are shown, folded mountains are shown. So some scientists, they are studying on this, and they have given their various compliments on this interior of the earth. Next one, there is a third slide which gives us the solid layer comprised of crust and asthenosphere, upper mantle. So these are the sketches which are being given, and here the inner core, outer core, after that comes a mantle, and after that crust which is given. So here 0 to 100 kilometers, this is the measurement which is given over here. So pedosphere, which is called as a soil layer, and hence a upper layer which is of a soil. After that comes the lithosphere is dynamic, changing, as we have seen the sketches, and in that lithosphere which is being acted as a change. So this change which had been occurred due to the various actions, and this action which is a dynamic action. So here temperature of the earth as heat from the center, as a temperature of the earth different, as a human being which is doing various actions on this earth, yeah, in the interior of the earth. So different borings and deep tunnels in the mines show that the temperature of the earth increases with increasing depth. As we go in the interior of the earth, yeah, deep and deep of the earth, the temperature it seems to be has increased as far as concerned to the depth. So the temperature increases by 1 degree Celsius with the depth of 32 meter. The hot magma that comes to the surface of the earth and the hot water springs that appear in the surface also give proof that the temperature of the earth increases with increasing depth. So at many places, so hot water springs are seen, and this is one of the example as Unap, which is near to the Chopra, and here also a water which water springs are seen, and hence this is one of the example. With this rate of the increase in temperature, the temperature of the earth at 80 kilometer depth will be 2760 degree Celsius. Some of the scientists thought that with the rate of increase in temperature, the material in the inner part of the earth must be in a liquid state. So in these slides we are observing that tides occur in the solid mass. Several proofs have been given by the various researchers that the interior of the earth is not in a liquid state, but tides occur if the solid mass of the earth crust extends up to 400 km beneath the hydrosphere. As tides occur regularly in the oceans, they show that beneath the hydrosphere there is a solid mass extending up to at least 400 km. After that, the suggestion which was given that if the Earth's interior is a liquid mass, it would gradually become solid and there would have been gradual decrease in volcanic activity. But this is not so. The number of volcanic eruptions has not diminished. Number third, next suggestion which was given that if the interior of the earth would have been liquid, the continents would be floating on it and the distances between them would have changed even a little. This does not happen. So, like the temperature, pressure increase with depth and the earth's interior is under enormous pressure. Due to high temperature in the interior of the earth, the rocks may turn into a liquid state, but the enormous pressure hinders this process. Hence, at greater depth, there is probably a liquid material which, due to enormous pressure, has acquired the properties of a solid. This led us to believe that the Earth down to a depth of 2900 km behaves as a solid. If the pressure is relieved even to a small extent, the underlying material is likely to become molten because of the high temperature and come to the surface of the earth if it is weak. So, while studying to the interior of the earth, the behavior of the earthquake waves, the sudden movements which are being acting part in the interior of the earth, those are a earthquake and volcanoes. So, as a part of the earthquake, the most reliable and accurate information regarding the interior of the earth is obtained from a study of the earthquake waves. These waves are detected with the help of an instrument that is known as seismograph. So, a graph record of an earthquake wave is obtained from the seismograph. This is known as a seismogram. So, here, the study of the primary and secondary waves, there are longitudinal waves and second waves, those are the transverse waves. So, this is the study as the earthquake waves, the velocity of those which waves decrease while traveling through the medium of low density, and here the radioactive isotopes have been given. So, the release of this heat causes the churning of the molten rock inside, release of heat through cracks, vents in the crust, and convection causes plates of crust to move about. As earth is having a cracks, and within these cracks a molten material which is thrown out due to these sudden actions, and hence the 99% of the rock inside the earth is greater than 2000 degree Fahrenheit, and hence a radioactive decay generates the heat. So here the next slide which is given as a above the earth, a atmosphere is present as outermost layer affected by solar radiation weatherings and erosions which are acting part on the upper layer of the earth, as we are calling it as a lithosphere. So crustal moments, those are given as 0.2 to 1.1%, and crusts which are being occurred, those are 4 to 43 miles deep. So the Fahrenheit, the temperature which is recorded as a 700 degree Fahrenheit to 1500 degree Fahrenheit, as which is shown in this slide, that the upper layer of the earth, from the land surface, that layer is called as a troposphere. Up to some extent is layer which is present, and hence on this in this layer a human being, yeah, living beings which are present, as plants are there, animals are there, various very micro animals are seen, yeah, in the water also, yeah, on the land. So such type of living beings which are present in this layer, and that layer is a troposphere layer. So above the troposphere layer, which is called as a stratosphere, and in this layer a ozone which is present, and above this stratosphere mesosphere layer, and next one, that is the thermosphere. So as this is the home of the atmosphere, means these are the layers which are present in the homosphere, and out of this layer, which is a exosphere, which is a heterosphere layer. So while studying to this, as uh, the layers, the outer zone of the lithosphere, this outer zone has formed the crust of the earth, as everybody is knowing that 71% of the which is covered by the water bodies, like as the oceans which are being present, those are Pacific, Atlantic Ocean, Indian Ocean. So 29% of the land mass which is present on this earth. The thickness of the lithosphere is uneven, varying between 22 and 40 km. The maximum thickness is found beneath the fold mountain ranges of the world, as the study which had been done by the scientists, researchers, as the Rockies and the Andes, while the thickness is much less below the large open oceans. So lithosphere is made up of two layers, namely Sial and Saima. As this is the plasticity of the layers, so upper part that suppose the flats is called as the astrosphere, inner core and outer core, as we are studying. So the inner core which we have seen, and outer core that also we had discussed. So Sial and Saima, these are the layers which are the outer layers, outer zones of the layers. So Sial, what is meant by Sial? This is the outermost layer of the earth. It is made up of crystalline rocks. The continental masses are made up of Sial. In large areas, these crystalline rocks are covered by sedimentary rocks. The rocks in this layer are mainly made up of silica and alumina, hence the name Sial after silica Si and alumina Al. Sial is mainly made up of light rocks like granite with a specific gravity of about 2.7. The Sial layer is highly variable in thickness. It is thick beneath the landmass and is nearly absent below the ocean basins. Next one, that is Saima. The surface separating the Sial from the Saima is known as the Conrad discontinuity. It lies at different depths below the Sial layer lies a layer of denser and heavier rocks. This layer is known as the Saima. It is mainly made up of basalt and related rocks. The major constituents name the specific gravity of this layer varies between 2.7 and 3. Ocean floors are mainly made up of Saima. What is Moho? Moho below the crust lies the second layer, which is known as the mantle. The surface of discontinuity between the crust and the mantle is known as Moho. The name is given after the Yugoslavia scientist Morovic, who discovered it in 1909. The speed of transmission of earthquake waves in the Moho suddenly rises from about 5 to 8 km per second, indicating an increase in rock density. Now, the inner zone, as we will see, that is a mantle. This layer lies below the outer crust and extends up to a depth of 2,900 km. The rocks of the mantle are rich in heavy iron magnesium minerals, as the specific gravity of these rocks varies between 3 to 5. It is mainly made up of diorite. The mountain building activities like folding and faulting, volcanoes and earthquakes originate in this layer. So this is the one of the example as Himalayan, yeah, Rocky Mountain, Alps Mountain. These are the examples which are been given. And Gutenberg had also given in his theory that he demarcated that the mantle from the core. This name is given after the scientist Gutenberg, who discovered in 1914. This continuity lies at the depth of about 2889 km, means roughly it is 2900 km. So in this discontinuity, the behavior of the earthquakes changes abruptly. The velocity of primary waves decreases considerably while secondary waves disappear completely. So here, as the layers we had seen, core or knife, this is the last point to be discussed of this lithosphere. The layers lies below 2900 km approximately it is given. So this is the layer as a core of the bryosphere. This layer is mainly made up of nickel and iron, and hence is popularly known as a knife. Its diameter is roughly 6436 km. Its specific gravity varies between 5 and 13. Latest research shows that this layer is made up of an inner and an outer core. The outer core is either in a liquid or plastic state, and the inner one is solid. Secondary waves do not pass through the outer layer, while the velocity of primary waves decreases while crossing this layer. This estimated temperature of this layer is about 3700 degrees Celsius. This layer is under tremendous pressure with an average density of about 10.5. So, as the lithosphere, we had discussed the interior of the earth, what are the layers, and hence here we are completing these slides. Thank you very much.